Hi everyone, this is Dr. V.S. Nishok from EC Department, SNS College of Technology. Here I am with my students Dayanidhi, Harini and Darshan and Gokul Raj to discuss the topic on IC555 timer. So it is a case study topic. So one by one my students will discuss about the topic. It starts from Harini.
I'm going to explain the introduction of this 555 timer integrated circuit. In the vast world of electronics, few components have a test timer like 555 integrated circuit IC. Introduced in the 1970s, the electronic component, this versatile and co-effective chip has become the project and designing electronics. From generating the accurate time, the 555 timer has more efficiency, co-effective. Case study explored the 555 timer as an practical example in both educational and industrial settings. By examining the 555 timer, we can gain valuable relevance and utility in modern electronics. Now we have the broken flickering lamp as an example for this case study.
Okay. Next, problem statement. The problem statement is a small bookshop need a consistent LED light for visionaries. But they were very expensive and outlay for their needs. They wanted a stable flickering, no random flickerings, low cost and low power consumption. So the solution is a 555 timer IC. 555 timer IC is an 8-pin integrated circuit that used for timing, pulse generation, and oscillator operation. It works in 3 modes: a stable mode for continuous pulse generation, monostable mode for short pulse generation, and bistable mode for act like a reset and set and reset mode.
Why we use 555 IC timer? Program needed. In microcontroller, we need to write a program. But in 555 IC timer, we did not need to write program. Just attach the components and working it. Basic building. In microcontroller, we need some of the other complex components. But in 555 IC timer, we need just simple basic components like resistor and capacitor. Low cost. In microcontroller is very high cost of simple and basic components. But in 555 IC timer, just 20 or 30 rupees. Like blink and LED, razor sound and delay for 5 seconds. 555 IC timer is done all the above this without coding. Instant feedback. How we can see the change in resistor and capacitor voltage. 555 IC timer do all of this. In simple projects like blinking and LED, razor sounds delay of 1 or 5 seconds. 555 IC timer is simple and easy and reliable to use.
Yes, here we can discuss about how we can implement and what are the challenges we can face. So first, let's discuss about how we can implement. We can implement by using a breadboard model. So we can face several challenges, but the main 2 challenges are the LED can blink too fast, and the second, it can drain the battery usage higher. So the first, the LED can blink too fast. Why does the LED blink too fast? If it doesn't use the perfect resistor for the LED, it can blink, it can produce the power alternatingly, and usage of the capacitor in the perfect mode. We already know that the capacitor always stores the energy level. If we use the perfect capacitor for the LED and the perfect resistors for the LED, we can control the fast flickering, where the resistor controls the flow of the electric current as well as the capacitor stores the energy level. If the both are in the correct manner, the LED can blink perfectly. And the second, it can drain the battery quickly. Why does it drain the battery quickly? I think it's of a resistor problem. If we use higher resistor level, using of 1 kilo ohm, above 1 kilo ohm resistors, we can save the battery. Because usage of high resistors, it gives more flow of electric current. At that time, capacitor can store more energy level. In that time, the battery saves more. By using this, we can implement this model and we can stop the electric current.
I'm here to discuss about the results and takeaways. Cost reliability. It is cost reliability 80% compared to the commercial solution set. And reliability. It can run over continuously for 6 months with zero failures. And scalability. It can reused for many multiple machines for consistent warning lines. And simple is powerful. It can be used without any complex circuits. It can be used with passive components. And no code, no problem. It can be done. We can solve this real world problem without any programming language. And old doesn't mean outdated. Even using a simple passive components, we can solve this problem without any programming languages.
Okay, as a conclusion of the discussion going here, we can say that these ICs outperform the previous conventional methods with its better features like power efficiency and then area, so and then finally the faster calculation. So everything these ICs will perform well and better than the previous methods. Thank you all for joining this video. You can join in the next video.